Meet Maya. She's a 6th grader who just got a math worksheet, and the very first problem says 3 to the 4th power. She stares at it. What does that even mean? Is it 3 times 4? Is it 3 plus 4? Maya has no idea, but she's about to discover one of the coolest shortcuts in all of math. Stick with us, and by the end of this video, you'll totally own exponents too. Let's go! So here's where Maya's problem starts. Imagine you need to multiply 2 times 2 times 2 times 2. That's 4 2's all multiplied together. You could write it all out, and the answer is 16. But what if you had to multiply 2 by itself 10 times, or 100 times? Writing it all out would take forever. That's exactly the problem mathematicians ran into, and that's exactly why they invented exponents. Think of exponents as a shortcut, a way to say, multiply this number by itself this many times, without writing it all out. Now let's meet the two superstars of this lesson, the base and the exponent. In the expression 3 to the 4th power, the 3 is called the base. That's the number you're going to multiply. The little 4 floating up top is the exponent. It tells you how many times to use the base as a factor. Together, they form what we call a power. So 3 to the 4th power means 3 times 3 times 3 times 3. The exponent is like a tiny boss telling the base what to do. Here's something Maya thought was confusing at first. How do you say these out loud? Let's clear that up. 5 with an exponent of 2 is read as 5 to the 2nd power, or the special nickname 5 squared. 5 with an exponent of 3 is 5 to the 3rd power, also called 5 cubed. Those two nicknames, squared and cubed, come from geometry, because squares have 2 dimensions and cubes have 3. For everything else, like 5 to the 4th power, you just say 5 to the 4th power. Simple as that. Okay, let's talk strategy. Maya figured out this simple 2-step approach, and it works every single time. Step 1. Look at the exponent and write the base that many times with multiplication signs between them. So 4 to the 3rd power becomes 4 times 4 times 4. Step 2. Multiply left to right. 4 times 4 is 16, and 16 times 4 is 64. Done! This process is called expanding the power. Once you expand it, the multiplication is totally straightforward. Maya said it felt like unwrapping a present. The exponent is the wrapping, and the multiplication is what's inside. Before we practice, Maya had 2 questions that totally stumped her. What happens when the exponent is 1 or when it's 0? Great questions. Any number to the 1st power equals itself, so 7 to the 1st power is just 7. Makes sense. You're only using the base once as a factor. Now here's the wild one. Any number to the 0 power equals 1, so 7 to the 0 power is 1. This seems strange, but it's a rule that keeps all of math consistent. Just remember it. It shows up on tests all the time, and now you know it cold. Let's try the same kind of problem Maya tackled first on her worksheet. 2 to the 5th power. Step 1. Expand it. The base is 2, and the exponent is 5. So we write 2 times 2 times 2 times 2 times 2. That's 5 2's. Now multiply left to right. 2 times 2 is 4, then 4 times 2 is 8, then 8 times 2 is 16, then 16 times 2 is 32. So 2 to the 5th power equals 32. See how each step just doubles the previous answer? Maya noticed that pattern right away, doubling every time. Now, 3 to the 4th power. This was actually the very first problem on Maya's worksheet. Base is 3, exponent is 4, so we expand. 3 times 3 times 3 times 3. 4 3's. Let's multiply step by step. 3 times 3 is 9, then 9 times 3 is 27, then 27 times 3 is 81. So 3 to the 4th power equals 81. Now Maya gets it. She stared at that problem for 5 minutes at the start of class, and now she solved it in seconds. That's the power of understanding exponents. Here's a fun one. 10 to the 2nd power, also called 10 squared. Base is 10, exponent is 2, so we expand. 10 times 10, and 10 times 10 is 100. That's it. Super clean. Here's a cool pattern Maya noticed. 10 squared is 100, which has 2 zeros. 10 to the third power would be 10 times 10 times 10, which equals 1,000. 3 zeros. The exponent tells you how many zeros follow the 1. So 10 to the sixth power would be 1 million. 1 million. Powers of 10 are everywhere in science and everyday life. 5 to the third power. 5 cubed. Base is 5. Exponent is 3. So expand. 5 times 5 times 5. 3 5s. Now multiply. 5 times 5 is 25. Then 25 times 5 is 125. So 5 cubed equals 125. Here's a fun fact. Perfect cubes get their name because if you build a cube that's 5 units on every side, length, width, and height all equal to 5, the total number of tiny unit cubes inside is exactly 125. That's why it's called cubed. Geometry and algebra working together. How cool is that? 6 to the second power, or 6 squared. Base is 6, exponent is 2. Expand. 6 times 6, and 6 times 6 equals 36, so 6 squared is 36. Here's where Maya's worksheet asked her to match powers to their values, and she nailed every single one. Perfect squares like 36 show up everywhere: floor tiles, chessboards, multiplication tables. Quick tip: memorizing the perfect squares from 1 squared through 12 squared is a huge time saver on tests. You'll recognize them instantly. Maya made flashcards. Maybe you should too. Let's flip it around. Instead of evaluating a power, can you write repeated multiplication using exponent notation? Look at 4 times 4 times 4. Count the 4s. There are 3 of them. So the base is 4 and the exponent is 3. That's 4 to the third power, or 4 cubed. Now try 2 times 2. Count the 2s. There are 2 of them. Base is 2, exponent is 2. That's 2 squared. And 2 times 2 equals 4. See how it works both ways? Maya said going from multiplication to exponent notation felt like putting things back in the box, neat and tidy. Remember when Maya stared at 3 to the fourth power and had absolutely no idea what to do? Look at her now. She can evaluate any power in seconds. Let's recap what we learned. The base is the number being multiplied. The exponent tells you how many times to use it. Expand the power by writing out the multiplication, then solve step by step. And don't forget the special rules. Any number to the first power is itself, and any number to the 0 power is 1. From totally confused to totally confident.